Hey folks, Serdar here for another episode of Dev with Serdar. And in this episode, we'll be looking at how to use Cython, the library for compiling Python to C in 2023. So what is Cython? It's a third-party project for Python that takes Python code and compiles it into a C extension module, a library written in C which you can import and use in your own Python code. So why would you want to do this? Well, Cython gives you several powerful features. It lets you easily write interfaces to existing C libraries, for one, but it also lets you use type decorations to annotate variables in your code as C types, machine-level integers and floats instead of Python objects. And for certain classes of problems, like operations involving arrays, this can make slow Python code much faster. So let's see an example of Cython in action. What I'm going to show off here is a version of a demo I wrote some time ago. It's an implementation of a mathematical game called Conway's Game of Life, and it simulates a colony of cells reproducing and growing according to a set of mathematical rules. I'm using the Piglet library to perform the visualization. Now, with the first version of the code, I've implemented the core rules, all the performance-sensitive stuff, in plain old Python. And they involve iterating through a two-dimensional array, and for each element in the array, doing some computation based on all 8 of its neighbors. You can check out the source code for this project at the URL in the video description, and you can see more details for yourself how it works and run the code on your own machine if you want to. Now, if we run this version of the code, the unoptimized version, you'll notice that this doesn't run very fast. According to the statistics we have here printing to the screen, it only manages about 13 or 14 updates a second because of how long it takes to compute each generation of cells. Now, let's take this code and feed it to the Cython compiler as is, without making any changes. And when we're done with this, you'll notice that we now have a PyD file in the same directory as our original Python module. This is a compiled library. This is what our program will now import instead of the regular Python module. On Linux, by the way, this would be a .so file. On Windows, it's .pyd. So if we run this version of the code, we'll notice that there's only a modest speedup. It's maybe about double the performance of the uncompiled version. And that's because the Cython compiler assumes that by default, every variable in this code is a Python object, a generic Python object. We still have to use the Python runtime with all of its overhead and all of its object handling mechanisms to do anything. So what would make this code faster? The answer is annotations. If we add Cython's custom annotations to this code, we could give Cython some idea of what C variable types that we could use in place of our generic Python types. And by using machine-native C types, we could speed things up tremendously. So to that end, here's another version of this file which uses custom Cython annotations. They tell us, for instance, that some functions in this module are meant to be compiled as C functions. In this case, some of these classes are C-style classes, and that some variables are meant to be C types. I should also note that Cython's syntax is a very odd hybrid of Python and C, so it doesn't play nice with Python linting tools. That is a drawback, but there's a partial solution for it, and I will go into that in just a few. So let's compile this type-decorated version of this module, this Cython syntax version, and let's use it in our program. And as you can see, this version runs orders of magnitude faster than the previous version, and that's because we're not using the Python runtime for the vast majority of the performance-intensive operations anymore. It's happening in pure C. It's not relying on the Python runtime. Here's another useful way for me to illustrate this very important point. Cython has a handy code reporting tool. When you compile a module with Cython, you get an HTML file that lists your code and has colored annotations with it. Yellow means code still has interactions with the Python runtime, so it'll probably run slower. White means it's pure C. So here is the code report from the first totally unoptimized version of this module. As you can see, it's almost entirely yellow. We did no annotations on it, so there are no performance enhancements. And these regions here, which is where we're doing most of our computation, these loops, are all yellow. Now, here's the version that has the type annotations. There's still some yellow in it, but they're not in the areas where we have our performance-crucial code. The actual loops in our function, where all the really performance-intensive stuff is, that's all pure C. So one of the things you can do with Cython is gradual transformation of your code into C. You can start with a pure Python version like we had before, which is not optimized but functional. You can add type annotations as you go and gradually turn it into pure C and speed it up by degrees. And you can experiment with this and find out which optimizations will be most useful. Now, you heard me mention before Cython's oddball syntax means that it doesn't play nice with Python's linting tools. Good news is there is a variation of Cython syntax that is 100% compatible with Python, and it's called pure Python mode. So here's an example of the same module, decorated with Cython annotations, but using pure Python mode. And the type annotations are in the same format as Python's normal way to do type hinting. The difference is that we import the Cython module into our code and we use types from that module to perform the hinting. There's also another really useful thing about pure Python mode. We can write code that will run as is in regular Python and compiled in Cython. So if we take this module and we run it as is without compiling it, we don't get speedups, but the code will run. You'll also notice here we have sections that have this if Cython compiled declaration. This is another very useful pure Python mode feature. It allows us to run code selectively. If this entire module is compiled, then we will run this branch of that code. If it's just plain old Python, then we run this branch. And this way we can alter the behavior of the code, which includes things like what to import and how variables are defined based on whether or not it's compiled. So that gives us even more flexibility. So let's feed this version of the code to the Cython compiler. And as you can see when we're running it, once again, we get massive speedups. And the code that we have can now also be handled by Python's native linting tools. So why wouldn't you want to use pure Python mode all the time? Well, there are some parts of Cython that are not yet supported in pure Python mode. One of those is if I wanted to import headers to wrap a C library. I can't do that in pure Python mode because the syntax doesn't yet support it. So if wrapping a library is one of your missions, you're going to need the non-compatible Cython syntax. But if you're just performing array manipulations or you're doing other math, pure Python mode should work fine. So to sum up, Cython lets us write C extension modules for Python in Python. It gives us a type decoration system to declare variables as C types, which can give us big speedups for numerically oriented code. And it has an alternate syntax that works with existing Python linting tools, although we can't yet use the full range of Cython functions with that syntax. So that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.